My name is Barry Zhang. This is my submission for Lab 1, Charge Tapes in the course Physics 2212. The purpose of this experiment is to experimentally calculate the temporary charge of a tape when quickly ripped from another piece of tape. The tape would otherwise be neutrally charged. See a brief preview of the results of the lab. In order to calculate this temporary charge, two main physics principles are used, including Newton's second law and Coulomb's law. A combination of these laws allows us to first calculate the force of gravity acting upon one piece of tape, which is then set in equilibrium with Coulomb's law in order to calculate the charge on one piece of tape. The system of this experiment is tape B, tape on the top. The surroundings are tape A, the tape on the bottom, and Earth. And the initial conditions are that the tapes are neutrally charged. With the data gathered from the experiment, we can calculate the charge of a tape. We can first use Newton's second law to calculate the force of gravity on the tape, shown here. Since we know that the tape is not moving, we know that the forces acting on the tape are equal and opposite in magnitude. The only other force acting on the tape is the electrostatic force. Using this knowledge, we can calculate the charge of the tape, that is shown here. From this knowledge, we can head into the first program, which models these interactions with the tape being a single point charge. In this program, I also calculated electron deficiency, shown here, as well as the ratio of atoms to electrons, shown here. Here are the results of this program. This is the model of tape B and tape A, as well as its interactions, the charge of the tape, the deficiency of electrons, as well as the ratio of atoms to electrons. Keep in mind that the red is the electrostatic force and the orange is the force of gravity. The program models the interactions as a line of charges rather than a single point charge. That is shown here. Here we see a line of charges tape B, the line of charges point A. The blue arrows represent the electric field created by tape A. The white line represents electrostatic force, and the yellow line represents the force of gravity. Here you can see the magnitude of electric force and the magnitude of the gravitational force. Here are the answers to the post-coding problems, with the magnitude of the single point charge, as well as the magnitude of the line of charges. Here, I calculated the charge of the tape when modeled by a line of charges, with the output of the second program, which is this number here. Some assumptions and approximations include that the force of gravity being set equal to the electrostatic force in the single charge calculations, as I mentioned, that the tape is not moving. And then for the number of charges in the tape is approximated. Some potential sources of error in this lab include the negligence of air resistance, humidity of the air, rounding errors, as well as calculation errors. And then for the what if and why questions. If electrons are positive and protons were negative, this would not change the results of the lab, as like charges would still repel and unlike charges would still attract. We know that the tapes have the same charge because they repel each other, which is why they float, or tape B floats. As for the why question, why are the values of the charge different? Well, the value of the charges are different because a line of charges will have more electrostatic interactions than a single point charge. This also means that a line of charges is more likely to be accurate than a single point charge because a long piece of tape is made of many, many atoms that each have a charge, rather than being a single point charge. And that wraps it up for Lab 1.